Problem number 7.2. The numbers in a triangular grapefruit pyramid, as we have seen in the previous question, are sometimes called the triangular numbers, since each number can be represented by an array of objects in the shape of an equilateral triangle. So this is the triangle case. You start from 1, then the next one, equilateral triangle, there are 3 points. Right? This is a layer 1, you have 1 point. Layer 2, you have 3 points. For layer 3, basically you extend this equilateral triangle out to have 3 points on one side instead of 2 points, like we see here. This little triangle is from layer 2. So the addition is really the number of points on that additional side. So for layer number 3, each side has 3 points. So the addition would be 3. So layer 2 versus layer 1, the addition is 2. And we can anticipate if for the next layer, layer number 4, versus layer number 3, I added in one more side, so the additional number of points would be 4. So let's confirm whether this is right. So for layer number 4, this triangle is the same as layer number 3. I added one more side, and each side there are 4 points. So therefore, the addition is 4. Then we can kind of anticipate for the next layer, we would have an addition of 5 points. So what does the next one looks like? Next one is an equilateral triangle with 5 points on each side. So 5 points on each side, we get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This triangle is the same as layer number 4, has 4 points on each side. The addition is this one side. Each side has 1, 2, 3, 4, 5 points. So students can go on for any layer. The difference between each layer are consecutive numbers, 2, 3, 4, 5, and so on. Similarly, we can do the same for square pyramids. It's the number of points in addition to the previous layer will be different, but the idea should be the same. First layer, you get 1 point. Second layer, you get 1 square, which are a total of 4 points. Then we need to extend this square into a square that has 2 points on each side. 3 points on each side instead of 2. So now you extend to this one. This square is according to the second layer. How many points have we added? We added one side and another side. So each side has 3 points. Remember, we have 1 point shared by these 2 adjacent sides. So therefore, each side is 3 plus 3 minus 1, which is the shared. So that's 5. So the difference now becomes 3 for layer 2 versus 1, and for layer 3 versus 2, the difference is 5. So is the next one difference 7? Let's find out. The next one, this square is the previous one, and now every side has 4 points. So I added one side and 2 sides. 4 points on each side and shared 1, so the difference is 7. So the anticipation is correct. So the next one difference is 9 and 11 and so on. Basically, you adding in 2 sides and minus 1 because they share. So now we need to talk about the pentagon. Pentagon is more complicated, but the idea is similar. First layer, you only got 1 point, right? And the second layer would be 1 pentagon. So that's total of 5 points. Next one, we want to have a pentagon that has, instead of 2 points on one side, we need to have 3 points on one side. We can extend these 2 adjacent sides out. So this one extends 1 more point. This side extends 1 more point as well. Now we need to complete our pentagon. This side is 1 point and then 2 points. All these sides are parallel to the inside pentagon. This one would have point 1, point 2 connect to here. So now we have the next layer. on the outside. Okay, the next layer, in addition to the previous one, has added one side, two sides, and three sides. How many additional points are there? Each side has 3 points. I added 3 sides. However, there are 2 points that's being shared. So the difference is 7 now. For this first layer, 5 versus 1, that's 4. So for this one, we extend that to the next layer. So this one has 3 points on each side. The next one should have 4 points on each side. Let's make it slightly smaller. Okay, here. If I extend this one out. So I have 1, 2, 3 now. Extend one side out, 2 sides out. Now you have 1 more point on each side. Parallel lines to the previous one, to the previous pentagon. 3 points. I need 1 more point. Now we can go back. 1, 2, 3, 4. Connect back. So now the outside layer is my layer number 4. So I added 1 side, 2 sides, and 3 sides. Each side has a number of points of 4. So I have 3 sides, 2 points are shared. So that will be 10. So the difference to the next layer is 10. When students do this, there are inside points too. But if you use the total number of points from the previous layer, you don't have to draw inside. For this one, you really have another pentagon right here. 1 point is layer 1. This is your layer 2, which is a single pentagon. And the third layer has 3 points on one side that goes to this one, and the fourth layer goes to that one. So you have all these inside points. If you only simply draw any pentagon, say layer number 10 has 10 points on each side, it's very hard to draw the inside points. But if you build your pentagon based on the previous layer, it will be much easier for you. Okay, we have hexagon numbers. Hexagon, it would be similar to this. Again, we want to build all our derivation based on the previous layer. The first one is a single point, and the second one would become this. You have 2 points on every side. Then we extend this one by 1 point. So now instead of adding 3 sides, we're adding side 1, side 2, side 3, and side 4. Each side has how many points? Each side now have 3 points. But students have to remember there are points that's being shared in this case, right? I have 3 multiplied 4, and there are 3 points being shared. So that's a difference of second layer, the third layer versus the second layer. This would be 12, this would be 9 points. And we can build upon this is extend again. Now each side has 3 points. Now we go to each side has 4 points. All sides are parallel to the previous layer. And you basically just do this. Again, now you would see you add in side 1, side 2, side 3, and side 4. Now each side has 4 points. I added 4 sides. Point 1 is shared, point 2 is shared, point 3 is shared, so minus 3. So that's 16 minus 3, that's 13 points. So the students can build your next layer based on the previous one. Now, if you use the previous one, as I said, all the inside points are included, it will be much easier for you to figure out how many numbers for the next layer.